Yesterday, you had a DMR that took a look at our review skills. We looked at graphing, geometry, measurement, and some computation. Let's go over this. It was your first week or first day with it. So if you have questions, I will pause after each problem for questions on how to solve. Use this graph to answer the question below. Let's make some noticings of the graph. I see we're selling t-shirts. I see there's two stores that are selling t-shirts, Jazzy's and Ultimate Tee. There are three colors being sold, blue, red, and green. And then down here, we see on this pictograph that each t-shirt equals 10 t-shirts. So the picture of half a t-shirt is 5 t-shirts. Okay, let's take a look at it. Which color and type of shirt has 5, 10, 15, 20 votes? It says which color and type. Okay, so our color is going to be here, blue, red, or green. Our type of shirt is going to be at the top, Jazzy's or Ultimate Tee. Let's take a look. This has 5 or 10, 20, 25. Nope, that's out. This has 10, 20. Okay. Jazzy's red has 20 votes. Any other have just 2 t-shirts? Nope. So there it is. Jazzy's red, red Jazzy's is the number of 20 t-shirts. Questions on that? Okay, next one. Choose all that are correct. And I did that all because even though you guys yelled at me last week, Miss Sousa, we get it. Okay, y'all got a big old fat F on that question on your DMR quiz because you didn't choose all and pay attention to the number. So all is 2. Which of these shapes has only one set of parallel sides? Remember, a set has 2 things in it. Just like a pair of jeans. It has 1 leg hole, 2 leg holes. So there's 2 things on it, but it's only 1 item, okay? So which of these has only 1 set of parallel lines? That would be object E. The top and the bottom are the set on this one object. That would also be, answer B, the left and the right are 2 objects, 2 things on one whole object. So B, E are your answers. William.
But both of them are off-center. They're not the same size.
Where does it say anything about size in this question?
Nowhere.
All right. Parallel means they're never going to touch. They're straight across from each other. That's the only vocab word we're working with here. It doesn't matter about their size. Hi, by the way, Vinnie Jackson. All right. Let's take a look at our number 3. Roddy plans to ride his bicycle for 55 minutes. So far, he has ridden for 29 minutes. How many more minutes does he have to ride? Okay, so total, he's gone 55. So far, he's gone 29. We've got to figure out what's left. So in order to do that, we're going to start with our total. We're going to subtract what we already have done. We've already done 29 minutes. I was doing this on the treadmill yesterday. I wanted to walk for 30 minutes. It was only at 11. I was subtracting how many more do I have to walk? 5 subtract 9 is impossible. So we're going to regroup. We're going to borrow a 10. 10 plus 5 is equal to 15. So now I've got 15 ones. 15 subtract 9 is 6. 4 tens subtract 2 tens is equal to 2 tens. So 26 is the answer. But I told Miss Thaxton she was wrong because I told Miss Thaxton that she had purple unicorns flying through space because she didn't put a label on her problem. And she said, oh my gosh, you're right, I didn't. And then we were okay. So make sure that you always remember those labels, even if teachers make a mistake and forget. Questions on that one? Okay. 4, read the scale to determine the weight of the object or objects. This starts at 0. It has gone to the 1. These 2 apples weigh 1 pound. Questions on that one? Yes, Leah.
If people did choose that, wow, because we've been learning about pounds
We have been
this whole time.
the whole time. Okay. Find the value of the variable. Variable is a word that we learned in our Mint Mobile Challenge. And we know that it is something that can change. A variable can change. So we are asking you to change this variable or letter into a number. Okay, so you're changing the M into a number. You guys use variables all the time, but 3rd graders freak out when you make them letters. Let me show you how you use variables. Boop. This right here is a variable. You guys know that it doesn't equal question mark. You know that you're supposed to put a number there. You guys also use variables all the time when you see this. 38 plus 39 equals blank. You guys know that the answer isn't blank. You know there's supposed to be a number there. So that's a variable. Another way you guys use variables all the time. 38 plus 39 equals box. Like on Prodigy. You guys know that this isn't box, that it's not square. There's supposed to be a number in there, okay? But for whatever reason, when we change it to a letter, 3rd graders go, ah! When you've done it as a line, you've done it as a question mark, you've done it as a box, it's the same thing. We just changed the picture into a letter this time, okay? That's it. So it's asking us to just solve the equation. 38 plus 39 equals what? 8 plus 9 is 17. Carry our 10, put down our 7 ones. 30 plus 30 is 60, plus another 10 is 70. 77. M equals 77. No reason to freak out. Just think of a question mark, a line, and a box. All we've done is make it a letter. That's it. Yes, William.
It was about the question before this one. It also says pound. It also says pound on it. It says pound.
Pound. So if you
Easy.
chose ounce, pounds, or inch, it does say pound right here, and there's only one of them. So I'll give you that, sir. Last one. How long is this object in inches? We have not gone to 1 inch, so the 1 inch options are gone. We are either at a 1/2 inch or 3/4 of an inch. 1, 2, 3. There are 3 hops, and I know from my pattern that goes 0, 1/4, 2/4, 3/4. 3/4 inch is your correct answer. Questions on that one? Alrighty. Beautiful. That's your DMR for today, friends. Okay. You will have your other DMR released to you today. Vinny, you got yours this morning from Ms. Sharp. Everybody else at 12:15. Make sure you are answering those questions so that you can get credit for your work for completion. That's it on the practice days. Did you complete it or not? Okay. All right. Today, we are going to take a look at some mathematical word problems that are involved with fairy tales. If you remember on Friday, we did one with a little red hen and weight and measurement. Today, we're going to take a look at Paul Bunyan with real world multiplication problems, okay? The reason we are focusing on fairy tales is because next week you are going to start designing your own comic book fairy tale. Paul Bunyan is one example of a fairy tale. I apologize, of a tall tale. And it is a legend of a very, very, very large man with a large pet blue ox. And he apparently has gotten a lot of credit for crazy things. Like this river right here, Paul Bunyan created that river by dragging his axe from a lake so that his ox could drink. Did that actually happen? No, but that's what the legend says. Okay, Paul Bunyan can also grab a tree and snap it off like a toothpick for his teeth. Can that actually happen? No, but it is what the legend tells us. Paul Bunyan also gets credit with his ox for creating mountains. I'm trying to see if they got a picture of that one. Because him and his ox wrestled one day and all the dirt they pushed around became a mountain. Did that actually happen? No, but it's just the silly stories we tell. Okay, today we're going to take a look at a Paul Bunyan story, but we're going to have to help him with some multiplication math because he's so large. We got to make larger groups of objects for him. Okay, so remember, on your seesaw, I pinned your Mint Mobile redesign. So if you click your activities, that's going to be up top. Scroll down one, and there's your Paul Bunyan real world multiplication problems. Okay, click on the add response, please. Hey, Paul Bunyan. He's got a song too. That's how it goes. All right, here is our task for today.
Today we will be reading a story about Paul Bunyan, and we will be solving problems involving multiplication. When you're as large as Paul Bunyan and Babe the Blue Ox, you need a lot of food. See if you can calculate the right amounts of food to keep our gentle giants alive. Also, we will be working on solving real-world problems involving multiplication of whole numbers within 100.
All right, let's get to it. Slide 2, let's review. What is a variable? This is from your DMR. This is what I just went over with you. You're going to see variables in your Paul Bunyan story. Here's what they are. Advertisement. Boo. Oh, it's not an advertisement.
$10.
Yay.
Let's say that I'm working in a restaurant and I'm making $10 per hour, but on top of my hourly wage, I also get tips each hour. So this entire expression, you can view this as how much I might make in a given hour. Now, you might also realize that the number of tips or the amount of tips I might make in an hour can change dramatically from hour to hour. It can vary. 1 hour, it might be lunchtime, get a lot of tips. People might get some big ticket items. The next hour, I might not have any customers, and then my tips might be really low. So the tips part right over here, we consider that, the entire word, we consider that to be a variable. From scenario to scenario, it can change. So for example, in one scenario, maybe it's lunchtime, I'm getting really big tips. So tips is equal to, let's say it's equal to $30. And so the total amount I might make in that hour is going to, we can go back to this expression right over here. It's going to be 10 plus, instead of writing tips here, I'll write 30 because that's what my tips are in that hour. And so that is going to be equal to, it's going to be equal to 40. Let me do it in that yellow color. It's going to be equal to $40. But let's say right after that, the restaurant slows down. We're out of the lunch hour for whatever reason. Maybe the restaurant next door has a big sale or something. And so the next hour, my tips go down dramatically. My tips go down to $5 for that hour. Now I go back to this expression. The total I make is my hourly wage plus the $5 in tips, plus the $5 in tips, which is equal to $15. As you see, this entire expression, the 10 plus tips, it changed depending on what the value of the variable tips is. Now, you won't see whole words typically used in algebra as variables. We get lazy, and so instead we tend to use just easier to write symbols. And so in this context, instead of writing tips, maybe we could have just written 10 plus t, where t represents the tips that we get in an hour. And so then we would say, okay, what happens when t is equal to 30? Well, if t is equal to 30, then we'd have, so what happens when t is equal to 30? Well, then we have a situation, t is equal to 30. This evaluates to 10 plus 30, which would be 40. What would happen if t is equal to 5? Well, then this would evaluate to 10 plus 5, which is equal to 15. Now I want to be clear, we didn't even have to use t. We didn't even really have to use a letter, although in traditional algebra you almost do use a letter. We could have written it as 10 plus x, where x is your tips per hour. X might not be as natural. It's not the first letter in the word tips. Or you could have even written 10 plus star, where you could say star represents the number of tips in an hour. But it just might have not made as much intuitive sense. But hopefully this gives you a general idea of just what a variable is. All it is a symbol. All it is a symbol that represents varying values. And that's why we call it a variable.
Okay, so we're talking as a waitress here, waiter or waitress. They make $10 an hour plus tips. Okay, tips this time, super, super, super busy, lots of tables, $30. This time, nobody came in, only one table, $5. So the amount of tips, Jalen, changes, but the expression stays the same. Okay, that T represents the amount of money. That's what we're going to use today in our Paul Bunyan, is a letter for some numbers. Okay, hop to slide 3, please. It says, read this to yourself. Please feel free to read along with me. I'm going to read this out loud to us. Do enjoy this Paul Bunyan story and see if you can find the drama. Paul Bunyan. I was a gigantic baby. As a newborn, I was so big that when I rolled around in my sleep, I knocked down an entire forest in Maine. That didn't really happen. My parents put me in a floating cradle on the ocean. When I kicked, I created such high waves that I flooded the coast of Maine. That didn't happen either. Once I was grown, I became a logger and single-handedly changed the geography of the United States. My crew and I cut down so many trees in North and South Dakota that the two states became flat as boards. With my giant hammer, I pounded down all those millions of tree stumps and made North and South Dakota nice and smooth. That didn't happen either. Babe, the blue ox, was my constant companion. I remember finding him as a calf one morning after I finished combing my hair with a rake. Babe had fallen into an icy river and turned blue by the time I rescued him. I used a forest of trees to build a barn for Babe, but the next morning he'd grown so much that he was carrying the barn on his back. Fully grown, Babe measured 42 axe handles between the eyes. That's not true either. I dug the Great Lakes so Babe would have plenty of fresh water. Then Babe's footprints made the smaller lakes in Wisconsin and Minnesota. That didn't happen either. He used to help me by hauling the logging camp over the mountains and plains to make camp at a new spot. Once, when the loggers set down the logs to the river too far, I fed Babe extra salt and led him to the Mississippi. He was so thirsty, he slurped up the river and sucked the logs back upstream. That didn't happen either. It was hard keeping Babe and the whole crew fed at the logging camps. Each logger was at least 7 feet tall and weighed 350 pounds. I needed a giant grill and 200 cooks just to make the pancakes for breakfast. Cookhouse boys on roller skates delivered food up and down the rows of tables because each table was 6 miles long. That's not true. As for Babe, he ate 50 bales of hay just for a snack. Well, those certainly were the good old days when Babe and the crew and I made our way across the United States. These days, Babe and I are retired in the backwoods of Maine. We spend a lot of time hunting and fishing. Believe it or not, our favorite pastime is planting trees and watching them grow. They can't really hold trees in their hand. All right, there's our story. Questions, concerns, comments? Levin?
Watch the real story.
We will be investigating the real stories next week. Yes, these are introductions. Get excited. All right, hop to slide 4. There were a lot of numbers up in there, miles of tables and axe handles to measure people and 50 bales of hay for a meal. We're going to figure out some equations we can solve here, okay? Read the highlighted selection of text, answer the question below. Here is your question.
Paul Bunyan cuts down 10 trees a day. If he spends 3 days cutting trees in North Dakota and 4 days cutting trees in South Dakota, how many trees did he cut down?
All right. So remember Paul Bunyan, once I was grown, I became a logger and single-handedly changed the geography of the United States. My crew and I cut down so many trees in North and South Dakota that the 2 states became flat as boards. With my giant hammer, I pounded down all those millions of tree stumps and made North Dakota and South Dakota nice and smooth. All right, let's figure this out, friends. Let's highlight our important information. Paul Bunyan cut down 10 trees a day. I'm going to write that down. The number of trees doesn't change. It's 10. So I'm going to write it down. 10 trees. If he spends 3 days cutting down trees in North Dakota and 4 days cutting down trees in South Dakota, how many trees did he cut down? So we're looking for the total number of trees. How many trees in all did he cut down? Okay, let's write this with a variable. The number of trees does not change. The number of trees is 10. 10 trees a day, no matter what day it is. Monday, Tuesday, Wednesday, next week, last week, it's always going to be 10 trees. What does change is the number of days. So let's put a D for days. Okay, so 10 trees times the number of days. That's what we're going to figure out. Let's do North Dakota first. Okay, look what it says about North Dakota. North Dakota was 3 days. So let's write that equation. 10 times 3 days in North Dakota is equal to what? Count by tens 3 times. Braden, 10 times 3 is?
30.
30. So the answer here is 30 trees. Let's write it down. So this was North Dakota. Now we're going to do South Dakota. South Dakota, again, the number of trees stayed the same. It was 10 trees in a day. However, in South Dakota, he spent 4 days. So now we're doing 10 times 4. Okay, Leah, 10 times 4 is equal to?
40.
40 trees, correct. 40 trees. Our question is, how many trees did he cut down altogether? So now what we've got to do is what, Willem?
Now we have to add them both up.
Correct. Now we're going to add up 30 plus 40. And Levin, what is that going to give us? 30 plus 40. What's that going to give us?
9. Well, 90.
Close.
Oh, yeah. That's 5 plus 4.
3 plus 4 would be?
No, not 8. 7.
Ding, ding, ding. Thank you for taking your time to find the correct answer, Levin. Excellent. 70 trees. And as Josh said to me in the chat, you better put trees or it's going to be purple unicorns flying through space. And Paul Bunyan's going to be very confused because I bet he's never seen a purple unicorn. Maybe he has. He's seen a blue ox. Who knows? Okay. So what do we do here? We used a letter to represent what changed in the problem. Okay. In North Dakota, it was 3 days. In South Dakota, it was 4 days. So we used that D to represent the number of days, and that changed from 3 to 4, depending on the state we were in. Questions on this one? All right, let's hop to slide 5, please. Slide 5, let's go ahead and listen to the question so we know what we're reading for.
When Paul Bunyan needed a toothpick, he used a log that was 4 feet long. Paul's ring finger was 4 times as long as his toothpick. How long was his finger?
All right, let's take a look. Once I was grown, I became a logger and single-handedly changed the geography of the United States. My crew and I cut down so many trees in North and South Dakota that the 2 states became flat as boards. With my giant hammer, I pounded down all those millions of tree stumps and made North Dakota nice and smooth. All right, so he's cut down a tree. He's going to use a log that was 4 feet long. 4 feet long for a toothpick. That's a long toothpick. Paul's ring finger was 4 times as long as his toothpick. How long was his finger? All right, so let's figure out what we know. We know that the log he used was 4 feet long. Let's write it down. There's my log. His ring finger was 4 times as long as that toothpick. So if something is 4 times as long, what do you think we're multiplying by, Tim, who has vanished? Tim, 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 Tim. Yay. Tim, if something is 4 times as long, what are we multiplying by?
What are we multiplying by? 4 times 4.
There you go, sir. Oops, not in the highlighter. My bad, my bad. 4 times 4. That ring finger was 4 times as long. 4 times 4 is equal to what, Aiden G?
16.
16 what's?
16
feet. It is 16 feet. Our answer is 16 feet. We did not need a variable in this equation because everything was given to us right away. On this, the number of days changed. On this equation, nothing changed. The log was 4 feet. The finger was 4 times as long as that. There was no change. So our variable was the answer. So imagine if there had been a blank or a line or maybe an F for finger or feet. That was our variable here. Okay? Questions on that? All right. Let's take a look at number 6, please. Number 6, here is your question.
The width of one of Babe's eyes is 5 times the length of an axe handle. An axe handle is 3 feet long. What is the width of both of Babe's eyes?
All right. So remember, we've learned about Babe here. Babe had fallen into icy water and turned blue by the time I rescued him. I used a forest of trees to build a barn for Babe, but the next morning he'd grown so much that he was carrying a little barn on his back. Fully grown, Babe measured 42 axe handles between the eyes. Okay, let's set this up and then you're going to go into a breakout room. The width of one of Babe's eyes. So let's draw Babe's eye. Get with me. Let's draw a little eye here. Boop. The width of one of his eyes is 5 times the length of an axe handle. An axe handle, let's draw an axe handle. There's my handle. There's my axe. An axe handle is 3 feet long. You are being asked to find the length of both eyes. 2 eyes. Or the width, I apologize. So you're doing this twice. Okay? I want you to hop into your breakout room and you're going to talk about how you can solve this together. Okay? We've got 2 eyes that are 5 times the axe handle. Yes, Aiden G, a question.
I was just gonna answer.
Well, you can share it in your breakout room, okay? All right, here you go. Hop in your breakout room, share your ideas. Screen sharing will be on for you. Your correct answer should have been 60 feet. Here's how we got there, okay? One of his eyes is 5 times the length of an axe handle. My first equation is right here. 5 times 3, oh, I apologize, 30 feet. My bad, my math's not right. 1 second. 5 times 3 is equal to 15 feet. Okay, that's one eye. We've got to do the same thing again for the other eye. 5 times the length of an axe handle is equal to 5 times 3, and that's going to give us 15 feet. When you put both of those eyes together, that will give you an answer total of 30 feet. I got too excited. I was thinking he had 4 eyes. He doesn't. Okay, 30 feet. Questions on that? Yes, Willem.
I had 30. I thought I was wrong.
You got it. My bad. Teachers make mistakes too. Yes, Leah.
I got 32.
Beautiful. You got 32 or you got 30 also?
I got 30 also.
Gotcha. All right, cool. Okay. Slide 7 has 2 equations. Slide 8 has 1 equation. All of these are multiplication equations, as is told by our title, Paul Bunyan Real World Multiplication Problems. Your independent task today is to complete slides 7 and 8, Justin. Not your basketball shots, but slides 7 and 8. Okay? Slide 7 has 2 equations. Slide 8 has 1. That is 3 problems to solve. That is your work for today.